how can something only 1,000th the width of a strand of hair cause up to 44 times the damage of the flu? For the SARS-CoV-2 virus or coronavirus, it's all in a day's work. It consists of RNA wrapped inside of a protein capsid, which is surrounded by an envelope dotted with spike proteins. Its goal is to replicate itself inside of a host cell and assemble a large viral army. But the breakthrough here is understanding its viral process, because that's the key to finding a cure. First, the virus uses its spike protein keys to enter a host cell via cellular ACE2 receptor locks. After the spikes are cleaved to the right shape using enzymes, they bind to the receptors, allowing the virus to enter the cell. Once inside, the virus hijacks the cell's machinery to replicate itself and assemble its viral army. First, the virus reveals its RNA so that the cell's ribosomes can make polyproteins. These proteins are cut into smaller proteins, including RNA polymerase, making up the replication transcription complex. RNA polymerase creates more copies of the viral RNA. These copies go to the rough endoplasmic reticulum, where more ribosomes make the viral parts. These parts are assembled and packaged in the Golgi apparatus to make the virus copies. The virus is now successfully replicated and exits the cell via exocytosis. Surprisingly, the complications of COVID occur because of the immune system's attack on the virus, specifically in the alveoli, the site of gas exchange in the lungs. After the infected cell releases cytokines and other signals to alert the immune system about the pathogen, the macrophage, an immune cell, comes to the alveoli and releases its own signals to begin inflammation. Some signals recruit other immune cells to come to the alveoli, but because the virus is so severe, they start going into overdrive and release too many cytokines and toxins. Other signals cause the capillaries to be more permeable, causing fluid to leak into the alveoli. Consequently, the alveoli is damaged and it collapses, leading to a lack of proper gas exchange, acute respiratory distress syndrome, and even death. Washing your hands with soap is one of the easiest ways to prevent infection, because the soap destroys the virus by breaking down its envelope. Both soap and the viral envelope are made of phospholipids, lipids with a hydrophilic head and hydrophobic tail. When soap and viruses interact, their hydrophobic tails attract, breaking apart the viral envelope. Though this interaction is too small to see with viruses, it can be seen with animal cells because they're also surrounded by a phospholipid bilayer. When I add soap to this cell solution, the lipid membrane breaks apart due to the tail attraction concept. This reveals the DNA inside the cell, proving that the bilayer has broken and that soap does indeed work. If scientists understand its viral process, then they can create a drug that inhibits the virus from completing a certain step in the process, preventing complete infection and ending this pandemic eventually. However, before this drug is released, we can take the right precautions and save lives. Thank you for watching.